So thank you so much for joining us. Our instructor for today is Fred Hunter from Sweetwater Collaborative, and we'll also have Barbara Wishingrad from Sweetwater Collaborative chiming in as needed. Take it away, Fred.
Okay, welcome everyone to our rainwater harvesting and stormwater management webinar. And let's just dive right in. Madeline, you'll be, thank you. So we're going to cover in today's webinar the principles of rainwater harvesting briefly. We are going to talk about the difference between harvesting rainwater and storing that in your soil versus storing that rainwater in tanks or cisterns. Would be a big topic of conversation. So let's go ahead and get into this, to the principles of rainwater harvesting. And what is rainwater harvesting? So obviously, rainwater harvesting is a process of capturing rain and making use of it as close as possible to where that rainwater falls in your watershed or on your property. So let's just get into the nuts and bolts of it. In the past, with rainwater harvesting, we used to treat rainwater as more of a nuisance, and the modality was to pave surfaces, pipe the rainwater, pump it away, and use rocks to cover areas. It was a pave it, pipe it, pump it, and use pebbles kind of a mentality. We used to treat rainwater as something that needed to be removed from a system. The newer, more evolved way of looking at it is the new school, which we refer to as slow it, spread it, and sink it. We want to try to retain that stormwater, rainwater, and use it rather than shed it from the property. So with in rainwater harvesting, the very first step to conduct when you're trying to consider rainwater harvesting for your property is to begin with observation. You want to take a good time to watch where the rain falls, where the rain flows. Water will always follow patterns on the property, and it's important to observe those patterns and see where the rainwater is going. And so a long and thoughtful observation is a very important place to start. You want to just really become aware of what the patterns are on the site, regards to how rainwater moves across the site. And it's helpful when considering the possibilities for rainwater harvesting on your property to start at the top of the watershed, namely the rooftops, the highest surfaces where the water will be collected, and then work your way down the watershed as you consider what the possibilities are for using that rainwater, for capturing that rainwater, for putting it to good use. It's helpful to sort of follow that downstream from that top to bottom approach, because the water will always flow that way. And if you begin your considerations at the top of the watershed, you will always end up in the right spot. If you start at the bottom and try to work upward, sometimes you end up with situations where you can't quite make the water flow the way you want to do it. So starting at the top of the watershed and working your way down is a great way to begin planning and conceiving of your rainwater harvesting system. So yeah, next slide. Then start small and simple. This is a very simple idea that even a simple, very small gesture, like a small basin around a tree, can be very effective way to capture and harness rainwater. Water will always follow the topography, so creating a simple low point that will intercept surface water and kind of cause it to pool and infiltrate can be a very simple way to begin rainwater harvesting. You don't need to do always very complex and involved systems. Sometimes just very subtle gestures in the landscape can be very, very effective. So don't be afraid of the simple maneuvers as a place to start. That's always a good starting point. And then there's a concept of reticulation, of moving the water back and forth across the landscape. This is part of our slow it, spread it, and sink it methodology. If you have a rather straight path from the source to the sink, you don't give the water very much opportunity to infiltrate. So we're always looking at ways to reticulate the path of the water, to move it from one side to a pooling zone and another side to a pooling zone. And the more often you can move the water back and forth, the slower its path will be across the property, and the more opportunities it's going to have to infiltrate into the ground. So the longest path between source and sink is a desirable attribute in a rainwater system. You want to try to figure out how you can hold on to that water for as long as possible. So also in considering these, the pathway of water, you've got to always plan for an overflow. In this drawing, and these are drawings that we're using courtesy of Brad Lancaster, who's really quite the expert in rainwater harvesting, and really has been an advocate for rainwater harvesting for decades, and is really quite a great source of information. And we use his drawings. I think they're very illustrative of what it is that we're trying to accomplish. You can see the watershed beginning on the roof and going into a rain tank. Well, that rain tank is going to fill up during the rain season, and it's going to have to overflow into the landscape. So you want to think of that overflow as a resource and plan for a basin around the tree that overflow would go into. Obviously, then that basin is going to eventually overflow and needs to have a path going down the downstream. So you always want to plan for the overflow. And even more and more as we seem to be impacted by the effects of climate change, the more extreme storms we tend to have. We may have fewer rain events, but those rain events that we do have may be more severe. So the potential for overflow from our systems is something we always need to have at the forefront of our minds. And we can see that overflow as a resource. So we work our way down the watershed, considering where the overflow from one gesture would go to the next, to the next, to the next. So that overflow is a valuable resource, but something we always must consider in designing a rainwater system. The other principle is we want to maximize the living and organic ground cover. This is what creates a sponge. In this image, you see this is a heavily mulched garden. It doesn't have a lot of green cover yet. This is a very early photograph of this particular installation. This was done in Carpinteria, and I think we have some slides of this same job later on in the presentation. But you can see how important it is that the entire surface area is covered in mulch. We don't want any bare ground that would become hard and resistant to infiltration of water. We want to always mulch or have planted areas. These are areas that are receptive and sponge-like, that are going to absorb the rainwater effectively. So it's very important to always mulch the ground and to encourage green ground cover wherever possible. Another concept, this is kind of a permaculture concept of stacking functions. You can think of, for example, in this drawing, we've got we're capturing water from the rooftop into a rain tank. That rain tank is then nurturing a fruit tree that's planted near the rain tank. Well, the tree is also shading and providing coolness to the house in the hot summer season with its foliage, while it's also benefiting from the stored rainwater in the rain tank. As well, that fruit tree is providing us a bounty of fruit It's also providing pollen and nectar for insects and pollinators. So there's all these complex relationships that form, but we want to think about the beneficial relationships and how they can be layered together in stacking functions. Something that that is just sort of a natural part of these systems. And then, of course, it's very important in this whole process, there's a feedback loop. You've spent time observing before you take measures, and then after you've done things, you want to observe what happens as a result, and then modify the system to reflect the changes that seem appropriate once you've had some thoughtful observation of what happens during the rain and as things mature. And so that constantly adjusting things to make them better after seeing what happens during when the system is functioning is very important as well. So we're going to talk about the soil as being a very important storage point for water. It ends up that the soil is actually the best place to store rainwater in your garden. When we do rainwater harvesting, we reduce the need for irrigation. We reduce stormwater runoff and ocean pollution. We reduce our maintenance costs for irrigation and gardening by having plants that are resilient. And we're also able to recharge groundwater. So putting water into the soil is super, super important. When you look at the cost analysis of, for example, rain barrels versus cisterns versus the soil, it becomes apparent that storing water in the soil is the very lowest cost solution, and it also yields the highest possibility of storage. A rain barrel is relatively inexpensive, but only holds 50 gallons of rainwater, which isn't a great deal of rainwater. You can have a larger cistern, but those are very expensive to construct and build or to buy, and they do hold a lot more water, but the cost of that water is much higher because of the cost of the infrastructure. Meanwhile, in the soil, the top 4 inches of soil on a quarter-acre lot can hold approximately 45,000 gallons of useful water storage. This is storage that's already in proximity to the roots of the plants that we're trying to irrigate. So it ends up that if you have healthy carbon-rich soil that has a high spongy capacity and can store lots of water, it ends up that is the very least expensive and easiest way to hold on to rainwater in your garden, is simply to bank it into the soil sponge. We're very positive about storing water in cisterns and rain barrels and such as that. It can be very useful to have that water. If it's stored in a cistern, you can use it to water specific plants. You can have it as an emergency source of water. So it's a very good thing to have a cistern or rain barrels. But as far as the sheer bang for the buck of storage, there's nothing like the soil for having the capacity to really hold on to that water so that it's very useful for our landscapes.
And actually, one thing about when you store in a tank or a cistern, the overflow always goes into the, well, we want the overflow to go into the soil instead of run out into the street. And that way, that kind of justifies using that, that kind of external storage.
So with rainwater harvesting, there are some basic calculations that are pertinent to know. For example, a 10 by 10 section of roof, that would be 100 square feet. There are 0.6 gallons, it's actually 0.623 gallons, but we usually say 0.6 just because there are certain inefficiencies in actually capturing all of the water that falls onto a roof. So 0.6 gallons per square foot is what is capturable off of a roof surface or a hardscape. So if you had 100 square feet, you would get 60 gallons of water. So in converting 60 gallons of water, trying to figure out how much storage you would need in your landscape for 60 gallons of water, there are 7.48 gallons in each cubic foot. So if you had 60 gallons, that would end up being 8 cubic feet of storage space you would require in order to capture that in the garden. So this is a way we kind of can calculate what size of rain basin we might need reasonably in the garden in order to capture the volume of water coming off of a roof or a hardscape. So if you're having a 1-inch rain off of a certain square footage, it's easy to calculate how many cubic feet of storage you would reasonably need to capture that and hold it in the garden.
And the thing is that 8 cubic feet can look very different. There are many different ways that you can sculpt 8 cubic feet in the garden, and you're going to see some examples in the following slides.
And also with regard to the cubic feet of storage, you want to consider the type of soil that you have and how quickly your soil is able to infiltrate water. If you have heavy clay soil, you probably want to spread that water out in a fairly large and shallow basin so that it has a better chance to infiltrate into the soil. If you have very sandy soils that infiltrate quickly, you may not need to spread that 8 cubic feet out very far. So you would modulate the size and shape of the basin depending on how long it takes for your soil to absorb the volume that you capture off of your hardscapes or your roof. So the site selection guidelines for rainwater harvesting, you always want to have your collection, your storage zone or your basin be downslope from your hardscape or your collection surface. If it's a roof, it's easy to have a part of the garden be below the roof. But sometimes if you're capturing rainwater that's being harvested off of a hardscape, such as a patio, you want to be sure that you have a zone for your basin that's downslope from that patio. This water will be flowing by gravity. When you're considering this, also you want to try to stay away from the foundation of structures. 5 feet is a sort of a minimum distance that we try to achieve away from a structure. If there's a basement to the structure or some sort of subterranean infrastructure there, you probably want to stay a little farther away, maybe 10 feet from the structure. And there are some specific code requirements within jurisdictions that vary, but just as a rule of thumb, staying away from the foundation is a good idea. Also, we avoid doing infiltration basins over septic systems where there's already infiltration happening from the septic system from a household. And if you have a zone that's already soggy, well, you certainly don't want to be adding rainwater to a site that's already soggy. So you would avoid that. Ideally, it should be a zone that has good sunlight, because the plants that are going to be an integral part of that system that will be tapping into that moisture that's being planted in the soil sponge are going to need sunlight to grow. So if it's a sunny zone, you can grow more diversity and more lush vegetation that will benefit from the rainwater that's planted in that zone. And then also, ideally, when we're creating these basins, we want to avoid the roots of trees, large tree roots. If there's a more open space, it's more ideal than being too close to existing trees. So those are just some general selection guidelines for the site. Swales are something that we use oftentimes a swale refers to a structure, to a basically a ditch. A lot of times in the permaculture world, you would refer to a swale as being something that's on contour or level, and it's an infiltration structure that allows water to slow and pool and infiltrate. But we also use swales for conveying water when we want to move water. These are oftentimes structured like dry creeks, so that when there is rainwater and the rainwater's flowing, it'll flow through the conveyance and look much like just a natural creek. The photograph there is an example of one that's moving water, and you can see that where a pathway crosses the creek, we've simply put a bridge to allow for passage over the swale. We use rocks to armor conveyances when water is going to be moving. We want to avoid erosion of the channel, so we oftentimes will line those channels with rock to prevent erosion in a conveyance where the water is going to be moving. When we're doing infiltration, we prefer to use mulch because that allows for complete absorption. It doesn't block the surface of the soil at all for infiltration. And so when we're conveying water and water's in motion, we need to protect against erosion. But then when water is pooling and infiltrating, we want to try to then open the soil up with as much organic material as possible. So conveyance swales are often rock lined like this in this picture here. The mulch basin is really the most important part of a rainwater harvesting system, a rainwater harvesting garden. The sides of the basin can be sloped about 30%. They can be armed in places where water might be moving, or if they're steeper in soils that won't retain that shape, you can line them with rock to retain the edge of a basin. But typically the bottoms of the basin are mulched. As I said before, we want to aim for the most porosity and absorptivity that is possible in a basin. So mulch is actually the perfect thing, because not only is it feeding the soil biology and encouraging earthworms and fungi and bacteria to be plentiful and creating high carbon, very fluffy, absorptive soil. It is just a great surface area for allowing that infiltration to happen. There's no substitute for biologically rich soil. And the longer that this mulch basin exists, and the more over time, the more mulch it receives, the more carbon is going to be incorporated into the soil in the base of that basin. So it's really a regenerative feature. In other words, it becomes more and more ideal. It gains greater capacity over time. So rather than certain rock vaults are sometimes used for rainwater harvesting, people will create a basin and fill it with rock, and then allow rainwater to fill in the voids in the rock and slowly percolate into the soil beneath. But these structures over time tend to get silted up and become less and less infiltrative over time, whereas a mulch basin becomes more and more infiltrative over time. It's a regenerative system that gets better and better the longer it's in place. The more the plants grow in, the more the soil biology is intensified, the greater the carbon content of the soil, the better the system gets. So compost tea is another thing that we sometimes apply in mulch basins to help seed that basin with beneficial bacteria and fungi. Compost tea is just a brew of beneficial soil organisms that tends to inoculate the soil and help boost the numbers of all the beneficials. And those are the things that will tend to improve the soil texture, the soil quality, the fertility, and the carbon content, which are all key towards allowing for greater infiltration of rainwater in the basin. Now here's an example of this will give you an idea of, this is a simple front yard, and you can see on the left the rough grading has been done. The basins have been carved out. And you'll see up at the left, there's a little lawn chair, and down at the right, you can see there's a van parked at the street. And that elevation drops a couple of feet from the top of the lawn down to the street. So we took advantage of that change in elevation to create conveyances that would carry the water, and then mulch basins that are sort of elongated. You can see it almost looks like a bath, like bathtub with basins there along the way that create spots for the water to pool. So those conveyances would be lined with rock, and the basins would be mulched heavily with mulch. And then the photograph on the right, you can see that's after a season of being, after the basins were mulched and planted. And you can see how happy and healthy the new plants are growing there along the edges of the basin. And so what started out as just a flat lawn that was relatively uninteresting as far as its topography, we created and sculpted something that it was has lots of relief and interest to it. And the plants are just super happy when you plant climate appropriate plants into a garden, and then you give them the additional rainwater in the rainy season. Those plants are going to thrive. If they're native California plants or Mediterranean climate appropriate plants, if they get a really good rain year, they're going to be happy for the entire year, and they're going to really look vibrant and healthy. And I think you can see that in the photograph on the right. What a beautiful garden, and how vibrant and healthy those plants look. Here's another case study, and this I think was the same garden that we saw a photograph of earlier when it was just mulched. On the upper left is just the front lawn that we started with, and you can see we've marked out with some gypsum powder on the lawn the rough contours of where we anticipated digging the rain basin. And then the other photographs show after the planting, the transformation. And you can see, if you look at those photographs on the right, you can just see the vigor and life that exists in that garden. It was really one of the most palpable transformations I've ever seen. The lizards and the insect life and the flowers and the vibrancy of the garden was just outstanding. We planted a very small, in this project, we planted a little fruit tree. It was a little cherimoya tree that was so tragic and sad looking at the outset. It was sort of an afterthought that the client had in a pot, and she said, could we use this in the garden? And we said, of course, let's put it in. We planted that little sad tree, and in a matter of a year or two, that little tree took off, and it's now just this enormous and healthy tree because it was so happy with the rich soil and the incredible water that was getting. So it's the transformation is quite amazing. And I think the lushness of the photographs on the right really speak for themselves as far as the what's possible with rainwater harvesting. The kind of vigor that it brings to a landscape is something that's really quite exciting, and something that I've been astounded with as a landscape contractor for 30 years. Starting to do rain gardens in the last decade and seeing how dramatically it affects the vigor and health of a landscape has really been quite a great learning experience for me, and something I'm really passionate about seeing as much of happen as possible these days. This is another example of a lawn transformation. The upper left shows the before picture. And this was a project where a more drought tolerant xeriscape type garden was desired. And so the rainwater basins were constructed into the center of the garden, and those areas are mulched. And the mulch is filled in pretty thickly in those rain basins so that they don't appear to be very deep basins. They simply appear as mulch zones. And then the rest of the planting in the garden is very drought tolerant, xeriscape type plantings with decomposed granite as the ground cover. So there is quite a bit of water being harvested from the roof of the house and going into the landscape and infiltrating, but we still have a landscape that manages to look very, drought tolerant and like a xeric landscape, but it would not need very much water, much irrigation water to nurture the landscape once it's established. With this kind of implantation of rainwater into the system, there's very little call for irrigation in a garden like this.
And I just want to mention the picture on the right, which is a different residence that just has a rain garden and a tank. Part of that is coming down from a tank. And also there's another rain garden from the backyard next door, which is part of the same complex, which comes down through a creek and comes into this rain garden. And we just need to, this is normally a hour-and-a-half class that we've cut down into a 45-minute webinar. So we just need to move a little faster, I think, because we only have about 12 minutes left in the class.
Okay. We'll speed through. These are just some more examples of conveyances. You can see the rock work and the places where the water moves. You can see bridges over spots where pathways cross the conveyances. So things can, rainwater gardens can be beautiful as well as functional. One strategy we also have used is to, in this photograph, this is a big panorama shot, so it's a little bit distorted in the perspective, but you can see to the left, the downspout coming off of the house is conveyed across an arbor, and then along the fence toward the right there, where it goes in above a retaining wall and then is plumbed all the way over to the far right. You'll see sort of a medallion against the wall. That is the spout from which the rainwater from the roof now exits. So when it rains, all the rainwater from the roof ends up at the top of the garden. Instead of being sort of lost in the lower part of the property, we were able to, because we're capturing the water on the roof, we were able to convey it all the way back to the top of the garden and release it at the top of the garden into a series of basins that flows downward. So we were able to actually capture that rainwater, even though the garden was a little higher than the floor of the house. So that's one strategy we've used quite a bit, is aqueducts to convey the water to upper parts of the garden. There are a number of great demonstration gardens around town that you can check out if you want. There's one at Spencer Adams Park, 1216 De La Vina. That's one that's easy to see. There is the Santa Barbara Association of Realtors at 1415 Chapala Street. Beautiful rainwater garden there. The Shot Center at 310 West Padre, another beautiful rainwater garden that you can look at. And then also in Carpinteria at the Carpinteria Water District at 1301 Santa Ynez Street in Carpinteria, another rainwater garden that was done there at that facility that captures quite a bit of rainwater and is an interesting evolution for that landscape there. Another one at the Wake campus of Santa Barbara City College, which is out on Turnpike Road at 300 North Turnpike in the in the parking lot and around the buildings there, you can see some rainwater harvesting projects that have been done there, and they're easy to see. Also at that Wake campus, there are some examples of curb cuts. And this is something we wanted to mention. It is possible to harvest water that doesn't necessarily fall on your own property. We call this run on as opposed to run off when stormwater is passing by that you might be able to access. Oftentimes it can be done, for example, off of the street by doing curb cuts. This would allow water that's in the gutter on the street to flow into a basin to water trees on the street. And there's some math there, some statistics on how much rainwater is capturable on a city street, and it's a staggering amount of water that's flowing down the street that could be captured and used to water street trees and such as that if we were only able to open the curb and allow that water in. I think we have some examples of curb cuts. Yes, these are a couple of these are in the at the Wake Center, and you can see how the curb has simply been opened to allow the stormwater to run off the pavement and into the garden, just so it has a chance to pool and infiltrate rather than simply run off of the hardscape. The other is a little rain garden on Salina Street. And that's taking water out of the gutter and putting it into just a simple basin on the roadside that allows what would be running down the street into the ocean, laden with any pollutants and such that might be on the city streets. This is capturing that and allowing that water to be infiltrated and the pollutants to be mitigated in the Mulch basin, which is a great place to mitigate hydrocarbons, and all kinds of things like that can be broken down in the soil rather than sending them into the ocean where they have very little chance of being biodegraded or processed. So those are curb cuts. Rainwater storage in tanks is also something that is we like to consider. You can direct downspouts into the rain tanks. You need to think about filtration and mosquito protection. Obviously, there need to be screens on the inlets and outlets for rain tanks so that mosquitoes can't get in there. And it is wise to have some kind of a leaf screen or something that keeps debris out of the tank. Any organic debris that gets in the tank will tend to damage the water quality. These tanks should be on a stable surface, such as concrete or gravel. And water can be stored in these tanks for an unlimited amount of time. You don't have to purge the water. It doesn't go bad in a rain tank, particularly if you allow the biological layer at the bottom of the tank to be undisturbed. There is a constellation of beneficial organisms, bacteria and fungi and algae and such that will grow and will actually serve to purify the water in the tank. So you don't have to worry about changing out the water or flushing the water and cleaning the tank. In fact, the Rainwater Capture Association advises against that and advises to retain that biologic layer at the bottom of the tank undisturbed so that the natural processes can keep the water pure. So let's move to the next. Here's some examples of tanks. And we have two different styles of conveyance to get water into a rain tank. We have a dry conveyance, which is there on the left. That's where the water goes from the rooftop and drops into the top of the tank. And that involves having to fly across open space sometimes to maintain an aqueduct at a high level so that the source is above the entrance to the tank. But it is also possible to use a wet conveyance, which is there on the other side, example of which on the other side. And in a wet conveyance, we would go down to the ground with the piping and then come back up at the tank. And the water pressure of water entering the system on the upper end pushes the water through the wet conveyance and into the tank. So you don't always have to fly through the air. The downside to a wet conveyance is that the pipe will remain wet. It will have water in the pipe. And so oftentimes we will put a small valve or a little device to bleed that water slowly out of the pipe, so that when it's raining, water will flow through the system and make it into the tank. And then when the rain is stopped and there's water in the pipe will slowly drain, or we can come and open a valve to drain the remaining water out of the wet conveyance. These are just for other examples of
Excuse me,
tank filling. Yeah.
Madeline, can you go back for a minute? There are a couple things that I wanted to say about that last slide. First of all, these white pipes, these pictures were taken before the pipes were painted. When you have PVC in the sun, it deteriorates and it needs to be painted. So just because these are white, please understand that these were like right when the project was being finished. Another thing is that for the wet conveyance, the top of the tank still has to be lower than the downspout in order for it to work correctly, because water will flow, will fill to the, how do you say that, finds its own height. And then I just want to mention something about the middle slide. The middle slide is showing that the inlet and the outlet are in the same pipe, and that is not what's being shown on either side, but that is a type of system that we've done a lot, which allows for a little bit more capacity in the tank when you do it that way. Anyway.
Yeah, so in these examples, you can see the what we call the rain head, the leaf filter there. As the downspout comes down, that device there is filtering out any leaves or things that might be coming out of the downspout from the gutter and filling the tank. And then the other there's the leaf, that's the rain head. Then on the right-hand side, that's another example of what Barbara was describing as what we would call the inlet is the outlet. You see that little funny hump in the pipe there, that rise in the pipe is when water's coming out of the downspout, it's going to go into the tank until the tank fills up to an elevation that exceeds that little hump. And once the rain tank is full, the water will simply continue to flow over that hump and down into the overflow pipe. So it just allows us to fill that tank completely full and to use the same pipe for the inlet and the outlet. So it's a simplification of the process. Here's some examples of rain tanks. The two on the right, that is a 5,000 gallon storage tank. That gives you an idea of how large that is. It's about 12 feet in diameter and about 6 or 7 feet tall. It's quite a large tank, but that's 5,000 gallons of storage in one of those. I think the smaller tank on the other side was a 2,500. Barbara, you might remember the volume.
It was 1,350.
1,350. So only 1,350 gallons, much smaller tank and more manageable. So this shows you that storage takes a lot of volume to store water. It's a large, it's a large footprint, a large tank to keep any significant volume of water. But still, really awesome thing to have. So the takeaways from the class are that with rainwater harvesting, we have more water supply, we have less runoff, more water for plants, more water for groundwater recharge, less flooding because there's less runoff. The more that we keep on site, the less runoff we're causing downstream, the less water use we have. We're able to eliminate some irrigation. And by putting rainwater in the ground and mulching, we have less evaporation. So there's more water for our plants to grow. Greater fertility and greater soil structure from the mulching. This is the best thing we can do is mulch our soils. We have healthier and more resilient plants that are resistant to disease. We're not sending, if we're mulching, we're not sending our yard waste to the dump. So it's not going in the landfill. So it's really wonderful to be able to recycle carbon content of our green waste into our landscapes, which is where it should be going, and not into a landfill. That's very climate positive, because the more that goes into the landfill, the more organic material that ends up in a landfill, that organic material ends up becoming methane, which is even a worse greenhouse gas than the carbon dioxide. And so putting it into the soil is the best strategy. And we're creating landscapes that are more resilient to climate extremes. We talked about how well this works for drought, and that we're saving water in the soil, but it also mitigates flood by reducing downstream runoff. It's also good for insulating the soil against freezing weather and against heat. Minimizes the evaporation from soil in hot periods of time. So it's the best thing we can do for our landscapes, is to mulch them heavily and keep that rainwater in the garden. These are some upcoming webinars. I don't know, Madeline, you may want to talk about these.
Sure, I'll chime in. So these are some upcoming webinars we have this spring, continuing our series. The next 4 are taught by Kathy Pray, our city water resources specialist. And then the last one on waterways native plants is taught by Scott Pipkin at the Santa Barbara Botanic Garden. So these are on our garden classes webpage, and you can also scan that handy dandy QR code with your smartphone camera and pull them up that way.